You are welcome in our YouTube channel Become a Master of CAD Design. In this video, we are going to complete our mold base assembly for die casting die. First, we are going to learn how to pan assembly. So go to up pan, select the top level assembly. In that case, mold base. We are going to little bit know about this assembly load option. Go to option. In another video, we are going to talk about this in detail. In that load option, we are going to use a folder. Component of our assembly is available in this folder. So we use from folder. Load option, we use all component will be loaded. We use fully loaded. This is important in that assembly in which we are going to use lot of link, curve and body. We use fully load option, so anything will not fail and update quickly. Next, which is very important, reference set. Use model reference set in that. So our assembly will be clean, no unwanted body and sketches will available inside our assembly when we use model inside our reference set. And you can also set this as a default setting. Press it OK. Now here, press it OK. Now our assembly is loaded. You can see here how the assembly look like clean, and here we can see the assembly is fully loaded. The save button, read and write, our assembly is fully loaded and fully updated. When you use always fully loaded assembly and work on that, there is less chance your assembly will fail or come some unwanted error inside our assembly. So in this video, what we are going to do, first we are going to add our support pillar and block, and then we are going to add our die resting pad. We understand how to adjust this height pad height. We add some ejector rest button. We add ejector and bumper rod hole inside our ejector back plate. We add some eye bolt and lot of things we are going to do inside this video. So let's start this video. This video may be long, but you get so many things in this video. So watch this video until end. Activate our support pillar and block. Hide this all assembly, so our sketch and support pillar only. Change this reference set to entire part, so we can link this sketch part inside our support pillar block part. So now we are in support pillar block part. Go to assembly, wave geometry linker, and we are going to link sketch. This sketches, which is our support pillar and block sketch. Now hide this sketch, or you can change this to model reference set. So our moving half assembly. Now we are going to measure the height from here to bottom plate. So go to analysis, measure, and here we are going to define a vector in this vector and select object, this object and this object. So that is 175. Okay. Now we are going to extrude this sketch 175. Go to home, extrude, and change the direction here. It can be changed according to your ejection height. When our ejection height change, our height pad height will be changed, and then our support pillar and block height also going to be changed. Now hide this moving half assembly. So our support pillar and block. We are going to provide a bolting hole from bottom side, and it will bolt in our moving housing. So I am going to show the moving housing. So you can see here that is our moving housing, and we assemble this support pillar and block in correct position. This will from back side of our moving housing, and it will bolt on the bottom side. So for a time we are going to hide this moving housing and activate our support pillar and block. Go to hole, and here we are going to simply add a bolting hole in center. Reverse the direction. The bolting hole we are going to use for M16. Press it OK. This will do all outside. Next, same, we are going to add a 16 screw clearance hole in this block also. So go to hole, create a sketch on top of this, define a horizontal reference and keep it default. We find 2 points, one here and one here. Now we are going to define a dimension. Here we are going to use work within work part only. So we can select the edges. We are going to use 20 here to increase the size. So you can see the dimension. Now our sketch is fully defined. Finish this sketch and apply same M16, and here we are going to use through hole. Press it. Go to mold base assembly. So our moving housing. Now we are going to move this backside. Now we are going to apply some constant here. Go to assembly constant. Here we are going to use touch and align. Press it OK. Now we can see the degree of freedom. There is one rotation degree of freedom and 2 transitional degree of freedom. We are going to use assembly constant and distance. This support pillar and block is at a correct condition, so we simply add a distance and press it OK. Add one constant this side. Now we are going to refresh this, check degree of freedom of this. So now there is no degree of freedom, so we need to take care of this distance when we update our mold base. For example, we are going to add some slide this side or this side. We need to redefine our distance tolerance for our support pillar and block according to condition. Now we need to provide a bolting hole for this support pillar and block inside our moving housing. For this, what we do, we activate our moving housing and hide this body for a time and go to wave geometry linker. Now we are in moving housing. Okay, now select this composite curve and select this top circle Okay, and press it OK. Make sure associativity is on. Press it OK. Now hide this support pillar and sketch and show the body. This is our link sketch for support pillar and block. You can see you can adjust this support pillar when you think we need to change the position or change the shape of this. This is only for example. You can update this shape and position according to design. So now we are going to add a threaded hole for M16 here. Okay. Okay, use 35 and 40 here. Press it OK. Hide this composite curve. So our support block, you can see here threaded hole is already provided. So make sure one support block or pillar provided backside of the diffuser and one in bottom side. Okay, minimum. You can also add more support pillar and block if there is a place. Now so our moving housing assembly, our support pillar is added and exactly touch to the bottom plate. Next, we need to add that out inside our ejector and ejector back plate. Activate our ejector plate. Go to ejector plate part navigator. We are going to open this ejector plate in individual window so we can see easily. Now we are going to change this to entire part. Sketch inside our ejector plate and link this sketch. Go to assembly wave geometry linker and link this sketch, which is used for our support pillar and block. Okay, now uncheck this sketch part. So the sketch is hidden. Now we use this sketch to create a cutout inside our ejector plate. So reverse this direction and use through hole. We are going to use subtract. We are going to use offset single side 2 mm. Support pillar is provide a support only, not a guide for ejector and back plate. The guide pillar is already added inside our ejector and ejector back plate. Is it okay? That is our sketch and that is 2 mm clearance. Now hide this link sketch. Add some chamfer in this side, this side, this side, and this side. 2 mm chamfer is okay. Press it OK. Now you can see the hole available inside our ejector plate. Now we are going to make sure there is no bolting hole inside this. When the bolting hole is come inside this, we need to provide another bolting hole. So in that case, there is no bolting hole inside our support pillar and block area. Open this ejector back plate and repeat this process. Now you can see our cutout is also provided in our ejector backplate and ejector plate. We can also a little bit change this bolting hole position. So for example here we are going to select this and auto sketch and change this position. This okay. Same here we are going to use 35. This is okay. There is so much space available here. And that is also okay. We also can provide more bolting hole, but we also need to provide so many things. It is okay. We only need to change this one and press it OK. This is automatically updated in our ejector plate and ejector back plate. So that is the advantage of working in parametric. This here, there is no problem, but we also can use little bit inside. We use 40. Okay. Now see the ejector plate. The position is already updated. Now we also need to add a chamfer on this support pillar. Go to chamfer, select this and this edge. Press it OK. Save this. Go to file, save all. So all part in this assembly will save. We successfully added this support pillar and block. Now we need to understand this one. The height of this. How to decide this height? This height decided all according to our ejection height. So in that case, our ejection height is maybe 75 or 6. Select the vector. Measure this to this. This is our injection height. This is 76. Okay, so this is 76 and that is 40. 76 plus 40 plus this ejector plate thickness plus our ejector back plate thickness plus the resting button thickness, which is 15 mm. So from here to here we need 15, which is already updated, which is 15. So 15 plus this height, which is 35, plus this height, which is 30, plus injection height, which is 56, plus this height, which is 40. That all is equal to this height, 175, which is our height pad height, and the support pillar height is also equal to our height pad height, which is 175. We will add our ejector rest button after adding a button and bumper hole. So we decide to add a ejector bumper hole for we add 530 UV machine pattern which we designed. So according to the manual of a machine, you will be find inside the site. This is the PDF. You can see the pattern drawing of UV 530. So we can see there is two type of symbol. One is like dowel and one is open, not filled. So these four are open and these are filled. So the difference between this here, which are like this mark about 14 hole, that is used for ejector bumper rod, can be connected to ejector bumper plate with nut. In this type of symbol, the ejector bumper rod not connected. So what is difference in not connected and connected? In which ejector bumper plate is connected is are working to eject the component and also come back the ejector system in the exact position. But when we use this hole, it only eject the component. We need ejector return pin to come back the ejector assembly system in correct position. We always use return pin for a safety purpose. When we use slide, for example, the slide is inside the component, and in bottom side the ejector pin is available. So when our ejector pin will not come back in desired position, it will dangerous to come back the slide. So in that case, we use this ejector bumper rod system. When we use the slide, use this type of ejector bumper rod. We recommended always use this ejector bumper rod. This is the layout of our pattern drawing of 530 UV machine. In this layout, we show tiber position and screw bush center position, and these are the ejector bumper rod hole, and these are simple ejector hole. We already know the difference between both. We use this pattern layout to create a hole inside our mold base for the ejector bumper rod. So we are going to assemble this layout inside our mold base assembly to the mold base assembly, and now we are going to assemble this. For this, we are going to add component open. So now you can see the component here 530 UV. You can make this type of layout for different machine which is available in your workshop or company. Is it okay? In this component there is only curve, so we need to use reference set to reference set one, which we make especially for that. Okay, so now you can see the curves which is available in this. Now we are going to assemble this in a correct position using screw bush hole position aligned with the screw bush hole position. This is the screw bush hole position. This is in opposite side. Move this little bit. Maximum time these are symmetry, this side and this side, but we are going to rotate this and press it. Okay, now you can see the screw bush center. Now we are going to hide this half assembly, and see this datum is exactly in the center of our diffuser or screw bush. Check this. Select this axis and the center of the diffuser, and you can see the minimum distance is 0, 0 exactly in the center. So we try to align this pattern layout with this datum coordinate system with this center position. So now we are going to assembly constant. We use touch and align and select this axis of screw bush center x-axis, and I am going to align this with our z-axis plane. Okay, this is aligned. Now we are going to align this axis, this y-axis, with our y-z plane. Okay, this is come in exactly in the center of our screw bush center. Okay, we are going to hide this bottom plate. Move this layout to top of this ejector bottom plate. We use assembly constant, use touch and align, and select this circle and select this top face. So by using this, it automatically comes on top of the bottom plate. Okay, now you can also check the position. I am going to hide this support pillar and block. Go to analysis, measure, for example, this plane and this axis. So this is minimum distance 0, it is okay. And again we select this plane and this axis. So the minimum distance is 0. Okay, now we confirm our screw bush center is in a correct position. we need to add a ejector bumper hole inside our ejector backplate, which is a threaded hole. So the ejector bumper rod is connected to our ejector backplate, and it is used to eject ejector assembly and reverse the ejector assembly. So we need to choose 4 hole which can be balance our ejector assembly. So we are going to choose this 4, 1, 2, 3, 4. We need to check also a bolting hole and ejector pin hole where is available or not. We can move the bolting hole little bit, but this is okay. This is not goes to our threaded hole. Now we are going to project a curve inside our ejector backplate. So activate our ejector backplate. First we need to check the degree of freedom of this pattern. So the degree of freedom. So you can see one rotation degree of freedom is now available. So for this refresh this assembly constant, and we need another circle. For example, this circle and this face, and press it OK. Now again we are going to check the degree of freedom. So there is no degree of freedom. So now our 530 UV machine pattern is fully constant. Now we are going to link some curve inside ejector backplate for a reference to create a threaded hole for ejector bumper plate. Go to assembly, wave geometry linker, and link some composite curve by this curve, this curve, this curve, and this curve. Now our curve is linked inside our ejector backplate, and we can also link this curve inside backplate. We need a through hole inside the backplate, but that we will create after completing our ejector backplate. So you can see this is a composite curve which we created ejector bumper. Now we are going to change this color so you can see this easily. Okay, these are the curve. Which thread we are going to use for our ejector bumper rod? So this is according to our tonnage standard. For example, when we use 250 tonnage machine, it is M16, and when we use 350 ton or 400 ton or 450 ton, it's sometimes M20 or M24. For more than 420 to 560, it may be M24 or M30 for more than 8. It is according to your machine tonnage and machine manual. So you can find this thread size inside your machine manual. So in that case we are using 530 machine tonnage for UV. So we are going to use M24 threaded hole. Go to home hole and pick the center of this. Okay, pick the center one by one and reverse the direction, and we are going to use metric thread here. Okay, and we use M24 thread. Okay, M24 which is through hole, and press it OK. Now our ejector bumper hole is added inside our ejector backplate, which is threaded hole. Hide this link composite curve. Save this. Now we also need to add a throughout hole for our bumper plate inside bottom plate. So the bottom plate. Okay. Now we are going to link same curve inside our bottom plate. For this we activate our bottom plate and create a sketch on top of this, and press a reference, and we are going to project this. For example, go to project curve, and we are going to project this curve. Press it OK. Now hide this body to confirm the same hole which we created in our ejector backplate is projected. Please confirm. So this, and finish this sketch. Now we are going to create a throughout hole for this. The throughout hole size is more than the size which is given in the pattern drawing. So in the pattern drawing we see the size is 30, so we can use minimum 30, but as a clearance we are going to use 35 mm throughout hole inside our bottom plate. So the ejector rod there is a clearance, so we pick a center point according to the curve we projected, reverse the direction, and we are going to use the diameter 35 through hole and press it OK. Bumper rod hole is created inside our ejector backplate and bottom plate. So sometime we add more ejector bumper rod. For example, this is for 530 machine tonnage. Some more ejector bumper rod is added in same die according to 450 machine tonnage. So the die can run on both machine. So it is depending upon your design and your feasibility study. You can add more machine tonnage inside this, and in that case when you add more machine tonnage, you need to write here this hole for 530 machine tonnage, and this maybe this hole for 450 machine tonnage according to that. So we can write this here. Okay, now hide this 530 UV machine pattern. This machine pattern you can design in AutoCAD or you can design in Annex also into machine pattern drawing. Now you can see we created this 530 text on curve. First we created this sketch by using this center reference 20 mm, and the distance is 40, and we define a center 35 mm, and then we use the text. For example, I'm going to show you text, and we use on face. So select this face and select a curve, and it will create a text on this. You can change the fit center, and you can also change the height. For example, I'm going to use 20 mm, so you can change this. Okay, and press it OK. Now we are going to extrude this. We select this curve and go to extrude, and we are going to use 1 mm deep. For example, I am going to use none in boolean, so you can also copy this geometry. We are going to use pattern geometry, and we can select this extrude to select all in one click, and we are going to use general, and we pick a reference point, for example the center, and to this center. Okay, so it will automatically create a pattern for us. Okay, and press it OK. These all are associative, so when you change the text in this, it will automatically change in all. So now we are going to subtract this. Target body is this and the tool body is this. So we are going to subtract this extrude and this pattern geometry and press it OK. Now you can see hide this text and this curve, this sketch. Okay, you can see the text is engraved inside our bottom plate. So when this bottom plate is going to be manufactured, this will be engraved, so we can easily know this hole is for the 530 machine tonnage ejector bumper hole. Okay, now we are going to hide this curve also. Okay, save this and go back to our mold base assembly. Now we are going to add our ejector rest button. We have already a part ejector rest button. Activate this part and hide all other part. Activate only ejector rest button and go to part navigator, create a ejector rest button part. So go to sketch, select our XY plane and define a horizontal reference, press it OK, and create a circle. For example, we are going to take a diameter of 30. You can also take according to your design or space. You can use 20 to 30 diameter of ejector rest button. So we are going to use 30 and finish this sketch. Now we are going to extrude this sketch. Go to extrude. We know the height we are going to plan is 15 mm. Okay, and press it OK. Hide this sketch, and now we are going to apply some chamfer on it. So apply a chamfer on both sides. We are going to apply a chamfer of 1.5. Okay, press it OK. Now we are going to create a bolt in center. For this we are going to use hole command, and here we use screw clearance hole for M8. Pick the center. Okay, here the custom is selected. We are going to change this to normal so we can get the exact size for M8. Here the limit of depth we are going to select through all. Okay, press it OK. Now our rest button is created for ejector. Save it. Now go back to our top level assembly and activate our mold base assembly to our ejector back plate. Yes, and we are going to assemble this. So for this so moving housing for a time, so we can know the direction of in which we are going to assemble. So we are going to move this little bit on top side. Okay, this side we are going to assemble. Okay, this is on opposite direction, so we need to move this and rotate this 180. Okay, and now we are going to apply constant. Go to assembly constant, and here we are going to use touch and align. Select this and this face. Okay, and press it OK. Now we can move this. For example, here is our guide pillar, so I want to put one rest button here, and now we are going to copy this more. Go to move and use here copy, and we are going to make copy of this here, and one we are going to provide here. This is not necessary to constant this rest button. This is only to match with our ejector backplate face and do not come in hide pillar area or this ejector bumper rod hole area. This rest button is going to be rest on this bottom plate. You can see here these are our rest button, and this is roughly placed, and that is okay. This is only for rest. There is no any requirement of this. This is necessary to give. So we approximately place symmetry. For example, here we are going to use this water, and this we are going to use yes, and if you want to control this with constant, you can define a constant distance constant to 1 by 1 from the axis, the side edge of our ejector backplate. We roughly place all of our ejector rest button. Now we are going to create a bolting hole for bolt this ejector rest button inside our ejector backplate. So for this, activate our ejector backplate and hide all other assembly. Only show our ejector backplate and ejector rest button. So this is our ejector rest button. Okay, we can see here ejector rest button is activated. Now we are working on ejector backplate, but we can also see the ejector rest button. Now go back to part navigator of ejector backplate and hide the body of ejector backplate for a time. And now we are going to create a link curve. Go to wave geometry linker and composite curve and link this curve. Select all bottom circle of ejector rest button. Okay, now hide this ejector rest button and show the body of ejector backplate. You can see this link curve. You can also change the color. Select and press the shift, and you can edit the display and change this color to red or increase the thickness of the curve so you can see easily. Okay, and now we know we use M8 inside our ejector rest button. So here we are going to use M8 hole. So go to hole and threaded hole we are going to use in this M8. Okay, and take the center of composite link composite curve which we created. Press it. Okay, now you can see it's created through all. This is not necessary. You can also create, for example, here we are going to use 20 and here we are going to use 25. This is not necessary you create through all. This is only for rest. So that is okay. And now you can hide your link curves and save this part. Go back to assembly and show our rest button. Okay, and show our assembly. Hide this bottom plate. These all are our rest button. You can see in yellow color. If we change the position, the threaded hole position will automatically change. For example, if we are going to unpack this and change the position of one, for example, we are going to change this position a little bit. For example, here we are going to place this side. Okay, and press it. Okay, now you can see the threaded hole is automatically updated. That is the advantage of using link curves and work in assembly environment. Now we already created our ejector rest button. Now we are going to create our die resting pad for our fixed housing and moving housing and for our height pad and bottom plate. So for this we are going to little bit move this lifting hole inside our fixed housing. So we are going to change this to 150, 120. Okay, 120. Is this lifting hole will automatically updated inside fixed housing. Now we are going to add a die resting pad here. If we have a slide in this side, bottom side, so we need to add a large height pad design. But in this case, we do not have a slide. We are creating a simple mold base which can use for every type of die, and we can modify this later according to our insert design. Okay, so in that case, we are going to create a simple die resting pad which commonly used in every die. First, we are going to design for our fixed housing. So we are going to hide this moving housing, only show the fixed housing. We are going to measure the distance from this face to this face. Okay, this is 230. Okay, for example, we are going to create a clearance 10 mm from top side and 10 mm from bottom side. Here die resting pad for fixed block part we already created. Activate this part, hide this mold, this assembly, activate this part. You can see the datum CCS. For reference, we are going to show our fixed housing, and now we are going to create a sketch. For example, here go to sketch, select our XY plane, define a horizontal reference and press it. Okay, now we are going to hide this fixed housing little bit. Now we are going to create a rectangle. From center we are going to create AK center, and we provide a width of our height pad is 70 mm. This is also 70 mm. Okay, and now finish this, and next we are going to extrude this 210. Press it. Okay, next step is add a chamfer here, 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 and this side. We are going to add a chamfer of 10 mm and hide this sketch and add a chamfer of 2 mm around the body. So Okay, now we are going to create a bolting hole, so we can bolt this die resting pad with our fixed housing. So go to hole and select a top face, define a horizontal reference, place it okay. We need to create a point, 2 point, one here and one here, and now we are going to define this. We use work within work part only, so we can select this dimension. We are going to use 30. You can change this according to your requirement, and this we are going to take 35, which is center of that. We are going to increase the text size so you can see the dimension easily, and that is automatically aligned with top. So you can see sketch is fully defined. Finish this. Head size we are going to use screw clearance for M16. Okay, and press it okay. In our fixed housing, fixed half assembly, and activate our fixed housing. And now we are going to move this little bit outside and create a approximate position. So we are in fixed half assembly and go to assembly constant. First we are going to apply touch align from this. Okay, and next constant we are going to apply is from top side to this. Okay, we need to create a distance tolerance for this. So we are going to right click and convert to distance. Okay, and now we are going to activate this, and zero distance we are going to use 10 mm. Okay, and we are going to move this little bit inside, and we are going to use the distance. Go to assembly constant. From here to here we are going to use 40 mm. Okay, purpose of this to rest the die. So same we are going to create a move and create a copy of this. We are going to use another side, same die resting pad, which is for fix half, and same we are going to assemble this. Go to assembly, and we are going to use touch and align first. So we are going to move this little bit. Okay, and now go to assembly and apply the touch and align with this. Okay, and again we are going to constant this with distance from here to here. We are going to use 40. Okay, and assembly from here to here we are going to use 10. Okay, now you can see degree of freedom. There is no degree of freedom, and here you can see also degree of freedom. There is no degree of freedom. So that is in correct place. We also need to add a hole this side. So sometime we can use this hole also to lift the die by using a rod or anything. So we are going to place a hole inside the center of this. When we add in one resting pad, it will automatically updated in our second resting pad. Now go to home, sketch, and select this face, apply horizontal reference, face it okay. Now we are going to create a hole. The hole diameter we are going to use we are going to use 25. Okay, and try to create this hole inside the center. So for example, the height of this is 10 by 2. Okay, that is the center, and from the bottom side we are going to use this 25 is okay. Okay, make sure you can see the sketch properly and finish this sketch. Now we are going to extrude this throughout, subtract, and this we are going to use through all. Press it okay. Now you can see our tie resting pad for fixed housing is added. Same method we are going to use in our moving housing and our height pad. We measure the height of this moving housing and create a clearance 10 mm approx from upside and downside, and from the side we place this at a 40 mm distance. So you can design this by yourself. Now you can see we design our die resting pad for moving block and die resting pad for height pad and die resting pad for bottom plate. We use same method as we use in our fixed housing. In our height pad we add this lifting hole on top of our die resting pad is M24, thread depth is 24 and the drill size is 30 in center of this die resting pad. We add this because in bottom of our die resting pad there is a lifting hole available in our height pad. So the lifting hole is covered by our die resting pad. So we add this hole on top of die resting pad. In fixed housing and moving housing, we can move this lifting hole when it come inside our die resting pad, but that possibility is not available in our height pad. And the reason we add this hole on top of this die resting pad because these height pad are not heavy so much, so we can handle this lifting hole on die resting pad. But we recommended do not provide a lifting hole on fixed housing and moving housing because these are heavy, so we recommended apply a lifting hole on directly to the fixed housing and moving housing. The similar method we use for designing a die resting pad for bottom plate. In that we use M12 bolt because these are smaller die resting at 38 mm and this thickness is 40 mm, so little bit have clearance. We give some clearance in backside and we add this resting pad. We aligned this resting pad on with top face. The size of our die resting pad is you can see we use 70 and 100 mm width, a little bit width larger than our die resting pad for fixed housing and moving housing. These are the 70 and 70, but the common thing in all die resting pad is the height from the ground. This ground here we use 70. From this to this the height is 70 in every. For example, for this is also 70 and you can also select this is 70 and you can also select this, these are 70. So this is important, all are equal. Our fixed housing, moving housing and height pad we provide a hole, but in that case that is not necessary to provide a hole. The next step is we need to add a threaded hole for our die resting pad inside fixed housing and moving housing and height pad and bottom plate. So we are going to add a threaded hole inside fixed housing, activate our fixed housing, hide all and show our fixed housing only, die resting pad for fixed housing. Now we are going to part navigator and hide the solid body of our fixed housing, and then we are going to create a link curve. Go to assembly and wave geometry linker, and here we are going to use composite curve. Select the top circle of the chamfer, same for other. Okay, hide this die resting pad and show the body of our fixed housing and show this curve. These are the link curve, so we can easily create a threaded hole by using this link composite curve. So go to home, hole, and here we are going to use a threaded hole for metric thread and M16. Okay, and we are going to pick the center of this. We use normal to face. Okay, select this and this. We use 30 and 35. You can see the preview and paste it. Okay, hide this composite curve and show our die resting pad. So you can see here the threaded hole is applied. The same method we are going to use to create a threaded hole for our moving housing. So the threaded hole is added inside our fixed housing and height pad and bottom plate. Similar we add in our fixed housing. Now we are going to assemble a manifold in our fixed housing and moving housing and assemble a lifting pillar in our fixed housing, moving housing and height pad. So first we are going to assemble a manifold. So we already designed a manifold. I'm going to append this in individual windows so you can see this. First we design a base plate for manifold. The size of this is 40 and the 45. You can change this size according to your design, and then we create a rectangle and extrude this. Then we pattern this in 120 degree, keep count, and then we are going to trim this to create a shape like this. You can also create this shape by using sketch and then unite this all, and then with circle at a 27 distance. The diameter of this is 13.5. This is a rough design of a nipple in which the cooling pipe going to be inserted. Okay, and then we create a hole, and then we array this nipple in this direction, and then we array this in circle, a 60-degree angle. The number of nipple is depend upon the number of cooling available in our fixed housing. So the manifold design is different for our fixed housing and moving housing. We use two manifold in fixed housing and two manifold in moving housing, one for in and one for out. So for example, this manifold is used for in, so the all cooling system in which the in pipe is going to be installed in one of these nipples. This manifold is assembled on our housing and going to be bolted with this. We can also provide a 4-hole if the manifold is large and heavy according to your design. This is not a fixed design. You can change this according to your requirement. So we are going to install this in our mold base. First we are going to install this in our fixed housing. This is the manifold. The manifold is generally installed on top of the die. First we are going to assemble this on our fixed housing. Our fixed manifold, this is called manifold, but you can change this name. For example, go to mold wizard, and here you can find rename and export the component. Select this and select manifold, and here you can see old name and new name. Here fix manifold and delete older component. Okay, yes, so our old component which is manifold is deleted and replaced with the name fix manifold. So we are going to install this in our fixed housing. Go to move, and we are going to rotate this. Okay, so we can near where the assemble area. So I recommended to assemble this near the top face of our fixed housing. So most of cooling pipe is came from top side, which is used for our spot cooling inside the insert, and line cooling is come from this side. So this is also easy to connect it to one of these nipples. So first we are going to assemble this one manifold, then we are going to copy this and assemble the another. Fix half assembly, and then go to assembly constant. We use touch and align. Select this face and this face. So make sure you are assemble this manifold on top side. Opposite side, in which we are going to install a die resting pad. Okay, and next we are going to create a distance tolerance from this face to this face. We are going to use 150. Okay, or okay, and the next distance we are going to use from this to this top face, we prefer to use 0. In any case we need to change, we can update the distance. So here we need to update the distance. For example, this is for height pad, this is for this fixed housing and fixed manifold. The distance we are going to increase this. For example, here we are going to use 130. Okay, 130 is okay. And make sure the rotation of manifold is like we easily connect the pipe with our manifold nipple. So inside this, so we can easily connect the pipe. Okay, same we are going to make sure this is there is no degree of freedom. So our first manifold is perfectly assembled. We are going to move this. The same we copy this, the same number of nipple used in other manifold. Okay, no copy, and we are going to rotate this. So come inside and press it. Okay, so these are used for in and these are used for out. So the number of nipple in fixed housing on both are same, because for example here we use a cooling. The in and out is always available in a cooling, so number of in and out is equal in our fixed insert also, and our fixed housing wherever we are going to apply a cooling. Okay, so for example we are going to assemble this also. So check the degree of freedom. So there are 3 rotation and 3 transactional degree of freedom. So go to assembly and assembly constant. The important thing is make sure about the direction of this nipple, so you can easily install the pipe for in and out. Fixed housing manifold is assembled in a correct position. Save this. Now we are going to assemble our moving housing manifold. So our moving housing assembly. So in this moving housing, the manifold is not assembled. So we are going, okay, now we are going to assembly and add component. open and manifold copy and place it. Okay. And now we are going to assemble this manifold on top of our moving housing. So move this little bit up and rotate this at a 90 degree. Okay, and again we are going to rotate this so we can easily install our cooling pipe in the manifold. So I recommended to assemble this moving manifold near a bottom face of our moving housing. So most of cooling pipe is came from this side. Okay, so we are going to use touch and align constant and select this face. Okay, you can see the size of moving manifold is larger than the size of fixed manifold, and the number of nipple is also increased. So it depends on the cooling line number. For example, we think the moving insert have more cooling than fixed insert, so we have installed this more nipples in. So we are going to apply distance tolerance from this face to this face. We are going to use 0. Okay, and for this face to this face we are going to use 130 in opposite side. Okay, this side. Yes, press it. Okay, now you can see the degree of freedom. There is no degree of freedom. Same we are going to use for out. This is for in, and we are going to copy one more manifold in moving side. For example, this is for out, no copy, and we are going to rotate this 90 90 90. Okay, this is okay. Okay, for example, we are going to rotate this 90 90 90. Now that is okay. Now we are going to apply the constant. For example, first we are going to apply touch and align constant. Now the check degree of freedom. So you can see there is no degree of freedom. Now we are going to show fix how assembly also. Okay, now we can see fix manifold and moving manifold is installed in our fixed housing and moving housing. So we can easily connect our cooling system. One is for in, one is for out. Same, one is for in, one is for out. The number of nipple is depend upon the cooling provided in our fixed housing and moving housing, and the number of in is equal to number of out. Okay, now we are going to assemble our lifting pillar. So you can see here the part is installed or not. The part is not installed, so we are going to install this. We have a part already created. So first we are going to install our lifting pillar and eye bolt assembly in our fixed hub assembly. So activate our fixed hub assembly and add component, open, and here you can see the assembly of eye bolt with pillar assembly. Okay, open this. Okay, so you can see here the eye bolt and assembly is assembled in our fixed housing. So we are going to move outside the assembly. So you can see here I'm going to open this individually, so you can see how we can create this. This is eye bolt assembled in our eye bolt with a pillar assembly. So for example, here first we created this extrude. The diameter of this circle is 75. It depends upon your design. So we design according to our fixed housing, and then we created this extrude 40. So we can apply the thread on this M40, and then we create a blend here to strengthen this and chamfer, and then we create this M36 threaded hole for our eye bolt, and then we add this hole for holding or tightening this pillar on our fixed housing. Same we use in this direction, and add a chamfer on this. Okay, and then we created this eye bolt. For creating this eye bolt, we use this extrude. The diameter is 30, and then we extrude this 45 and apply thread on that. Okay, and then apply radius and apply chamfer, and created this sketch. The center is this, and the PCD is 80 and 55 mm away from this face. Okay, and we apply a tube on this. Okay, the tube diameter we use 20 and the inner diameter we use 0, and then we unite this and apply radius on this, and apply a external thread on M36 on this. Okay, so we can design this eye bolt with assembly. Now the same I volt we are going to use for fixed housing and moving housing. There is no change in length or something. The same can use for fixed housing and moving housing. So first we are going to assemble this on fixed housing. The simple one, we use this constant and select this bottom chamfer edge and select this edge and reverse the direction, so it will automatically assemble. Apply. Okay, the same copy we use, for example here copy and one more copy, and we use assembly constant, select this bottom chamfer and this bottom face and apply this. Okay, you can see the I bolt and pillar is assembled. Same we are going to do with our moving hub assembly. So activate our moving hub assembly, hide this fixed hub assembly. In moving hub assembly we have need 4 I bolt with pillar, lifting pillar, so we can use in our moving hub and also with our height bed. So we are going to assemble this, add component, open and add this assembly. Okay, now the assembly is loaded. Move this. Okay, and we are going to copy this first, 4, 2, 3 and 4. Okay, now we are going to assemble this one by one. For example here select the bottom face and this face and reverse the direction, apply. Now our lifting pillar is assembled inside our fixed hub assembly and moving hub assembly. You can see approx our mold base, standard mold base is complete. Now in next video we are going to talk about the standardization of mold base. So for different tonnage of machine we use different thickness for our guide pillar and guide bores and the thickness of our moving housing and fixed housing. Okay, so that we will discuss in next video. So for this video the standard model base is completed. Now try to make a complete die design tutorial in this channel. We are looking for a component design, so we can design a die according to that. If you have a suggestion you can comment. You have any component available for design which we can show in our channel, you can suggest us or comment us. Thank you for watching. We will meet on next video.